Imagine two moons, both sheathed in ice, each hiding a vast ocean below. Europa orbits Jupiter, and Enceladus circles Saturn. Scientists think both could host life, but how do we find out? NASA once planned to send a lander to Europa, designed to dig through the ice and search for signs of life. But before it could launch, the mission was shelved. Now what if that same lander could go to Enceladus, a world with shooting geysers and maybe an even bigger promise? The Europa Lander was meticulously designed and built to be a robotic scientist, a marvel of engineering poised to embark on a groundbreaking mission, landing, a feat of precision, on the enigmatic surface of Europa, digging with specialized tools designed to penetrate the thick ice crust, and searching diligently for any signs of life, past or present, hidden beneath Europa's icy shell. It would scoop up precious samples of ice carefully collected by its robotic arm, melt it within its onboard laboratory, and then meticulously test for the presence of chemicals and organic compounds that life, as we know it, needs to thrive. But space missions, especially those pushing the boundaries of exploration, are inherently tough and incredibly expensive endeavors. Europa's particularly harsh radiation environment, coupled with the challenge of penetrating its thick ice layers, made the lander mission exceptionally risky and consequently very costly. Faced with these challenges, NASA strategically shifted its focus, prioritizing the Europa Clipper mission, which, while still ambitious, will only perform flybys of the moon rather than attempting a landing. As a result, the lander project was paused, its future uncertain. But the dream of exploring icy moons and the tantalizing possibility of discovering life beyond Earth lived on, fueling the imaginations of scientists and space enthusiasts alike. Scientists began to wonder, considering alternative possibilities and new avenues for exploration. Could this highly specialized robot designed for Europa potentially work just as effectively, or perhaps even better, somewhere else in our solar system? Meet Enceladus, Saturn's small but fascinating moon. In 2005, NASA's Cassini spacecraft discovered geysers blasting water and organic molecules from its south pole. These plumes offer a direct sample of the ocean below, no drilling required. Cassini found salty water, organics, and hints of energy sources for life. Enceladus's ocean could be just as promising as Europa's. All we need is a lander to catch and analyze the falling ice. Europa and Enceladus, two celestial bodies residing in our solar system, share a fascinating resemblance. They're like cosmic siblings, each orbiting a gas giant, Jupiter and Saturn respectively. Both are characterized by icy shells, a frozen exterior that conceals a remarkable secret: hidden oceans of liquid water beneath the surface. These subsurface oceans are what make these moons so intriguing to scientists. Both Europa and Enceladus have water, a fundamental ingredient for life as we know it. This shared characteristic immediately elevates their status in the search for extraterrestrial life, and both are believed to possess energy sources potentially in the form of hydrothermal vents and the right chemicals, the building blocks necessary for life to emerge and thrive. But despite these similarities, Europa is significantly bigger, a more substantial world compared to its smaller sibling. It also boasts a thicker ice layer, a more formidable barrier separating the surface from the ocean below. And Europa endures intense radiation from Jupiter, a harsh environment that poses a significant challenge for any potential mission. In contrast, Enceladus is smaller, a more diminutive moon gracefully orbiting Saturn. It features a thinner crust, offering a potentially easier pathway to access its hidden ocean. And most remarkably, Enceladus has geysers that dramatically spray ocean material, including water ice and organic molecules, directly into space. The radiation environment is much lower on Enceladus, making it a safer and more hospitable destination for spacecraft. This lower radiation, combined with the accessibility of its ocean, makes it friendlier for robots in future exploration. Europa's ocean might be older, potentially harboring life for a longer period, and deeper, a vast and unexplored realm. But Enceladus gives us easy access to samples of its ocean through those magnificent geysers, allowing us to study its composition without even landing. Each moon has its own unique set of mysteries and challenges, presenting different avenues for scientific discovery. Europa is tough to reach, requiring spacecraft to brave the intense radiation belts of Jupiter. But Enceladus offers a shortcut, a direct pathway to sample its ocean through its plumes, making analysis far simpler. Both Europa and Enceladus are top contenders in the search for life beyond Earth, holding immense astrobiological significance. But Enceladus, with its accessible ocean and relatively benign environment, might just be the easier place to start our quest to answer one of humanity's greatest questions. Are we alone? The Europa Lander mission is designed to explore the icy surface of Jupiter's moon, Europa, in search of potential signs of life. But what if we considered a different destination? What if we sent the Europa Lander to Enceladus instead? Enceladus, another icy moon orbiting Saturn, boasts impressive geysers erupting from its south pole. It could land near these geysers, offering a unique opportunity to study the moon's subsurface ocean. The lander could then scoop up fresh ice ejected from these geysers, providing pristine samples from the interior ocean without the need for extensive drilling. These samples could then be analyzed by onboard scientific instruments to search for biosignatures and other indicators of life. It could search for life. The tools designed for Europa, with their advanced capabilities for detecting organic molecules and other signs of life, would work perfectly on Enceladus, allowing scientists to conduct similar analyses in a potentially more accessible environment. Enceladus also experiences lower radiation levels compared to Europa, and thinner ice near the geysers, making sample acquisition easier and less energy-intensive. This lower radiation and easier access to samples mean the lander could last longer on Enceladus's surface and do more science, gathering a more comprehensive data set and increasing the chances of a groundbreaking discovery. We could even catch falling snow, those icy particles raining down from the geysers. Maybe even find alien microbes, providing definitive proof of life beyond Earth. Repurposing the lander, adapting its mission to target Enceladus, saves time and money, allowing us to potentially accelerate the search for life in our solar system. Every scoop of ice, every sample analyzed, could bring us closer to answering the fundamental question that has captivated humanity for centuries. Are we alone in the vast expanse of the cosmos? Exploring Enceladus with the Europa Lander could change everything. We might finally discover life beyond Earth. Enceladus is offering samples from its hidden ocean, almost inviting us to explore. Using the Europa Lander here is smart, efficient, and inspiring. This mission could spark a new era of discovery. With every lander and every sample, we get closer to solving the greatest mystery. The universe is waiting. Let's go see what's out there.